Okay, so the power law is the most important law here, I would say, because this is really the only way that you can solve without trial and error and guessing and not being very exact. It's the only way you can solve for a variable in the exponent position. If the bases, like if these bases cannot be written in the same power. So the easy examples would be where you could rewrite the bases with the same power, then you could focus on the exponents. But for most cases, if we're just solving a random equation where we have an exponential equation here to solve, then we need to use logs. And this is how you do it. So taking the logarithm of one side of an equation is sort of an operation that you can do to both sides of the equation that will not alter the equality. So what I'm saying is that you can actually take the logarithm of this whole side, because it's just one term, easy, and the logarithm of this whole side, just one term, and that retains the equality of the statement. Okay, you can do that. Now, why is that important? Well, because what you want to notice is that you can use this power rule. So let me just rewrite this here. So log of 17 to the power of x equals log of 5044. Now the power rule says that this x, or this exponent, can come down as a multiplier. It can really just move as a multiplier, and that's what we're going to do. We're going to write this as x times log of 17. So notice that the x is no longer in the exponent position. It's no longer an exponent at all. The log sort of undoes that to the power of 2, right? That's an opposite operation. So 17 to the power of x can be undone by taking the logarithm of 17 to the power of x. So logarithm and to the power of cancel each other out. And this x turns in just a regular number that I can do mathematical operations on. Okay? And so over here, log of 5044, let's just see what that is. Let's clear this. Log of 5044, that's going to be some decimal. So 3.702, let's say. Okay. Now, notice what's happened here. I've kind of separated, and I can separate the x and the log of 17, which is just a constant. That's a constant now. I can separate them by just regular algebraic means. So I can actually isolate for x here by dividing both sides by log of 17. Because again, log of 17 is just a constant, and it's a factor. Now I can divide that out. So I have x equals, and I just do this on my calculator. I'll leave that number on there, divided by log 17. It's as easy as that. 3.009. Okay. Now, so if we have, so see, we might have sacrificed some precision here, but 17, now if I check this, 17 to the power of 3 is not quite 5044, but if I do 0.009, 17 to the power of 3.009, I'm going to get pretty close. And if I used all the decimals, these right here, then I should get that exact number. Let me see if I can do that actually. Entry. Oops. Shoot. Okay, well, not easy to get back there, but log of 5044 divided by log 17. I'll rewrite it, I guess. Log 5044 divided by log of 17. Oh, to the power of. Wait, what? To the power of? Oh, yeah, that hit the wrong button. Okay. I see. Yeah, see it to the power of there? Okay, disappointment. Let's go back. Let's change that to divided by. Thank you. Hit the right button. Look at that. Okay. So now 17 to the power of this whole decimal. That's what I'm after. Let's do that whole decimal. What? Hello? Equals. Thank you. Get that? Yeah, thank you for the applause. Okay, beautiful. Just for next time, I will screenshot this, and that'll be my little check. Okay. Hello. Hello, computer. Okay. So x is, oh. I love technology. I love technology. Okay, come on. Where I can see you. Good. Got it? All right. Let's do another couple examples here, and then I'll set you free on your own assignment, so you can do this all on your own. Okay, so if I was to take something like this and rewrite this in terms of the properties. So that's log of a, b, cube root c, base 7. So log of a, b, cube root c, base 7. If I were to rewrite that using the log properties, what I would want to notice is a couple things. I've got a times b times this cube root thing here, right? So I've actually got some products here. So I'm going to go log of a base 7. And because they're products, what do? Add, subtract, multiply, divide. I add log of b base 7. So that's what, the multiplying, see? Now I'm going to multiply again here by cube root of c. So I'm going to add again log of, I can write that as cube root of c for now. That's the first step of kind of using the properties to break this down a little bit. Everyone see that? These are three things right here, boom, boom, and boom, that are multiplied together. All right. So in this example, we're just kind of rewriting this and simplifying. Now, I'm going to simplify this one a bit more. Why? Because this is actually log of c to the power of what? What is that? Yes, thank you. Log to the power of 1 over 3. So it's c to the power of 1 over 3. If you have a cube root, that's to the power of 1 over whatever this index is here, the index of the root, 1 over 3 in this case. So using the power rule, how can I rewrite this further? How can I rewrite this last one? 1 over 3 times log c. Okay, so I broke this down into using the the logarithm laws into a sum of 3. Okay, very good. Okay, now how can I do the same thing to actually break this down a little bit and to solve this possibly without a calculator? Well, if you're asked to solve this without a calculator, you would use the rules. Okay, so using these rules, we have. Well, this is going to be 27 times root 3, and root 3 I can rewrite as 3 to the power 1/2, I guess. So I'm going to go log of 27 base 3 plus log of, now square root of 3 is 3 to the 1/2 base 3. Okay, well this helps out a lot because actually I can simplify this right now. I know the answer to this. That's pretty easy. 3 to the power of what gives me 27? That is? Yeah, it's 3. So this is 3. Oops, let's go yellow. That's 3. Now this right here, I could bring this 1/2 down in front, couldn't I? That's going to be 1/2 times log of 3 base 3. What's the log of 3 base 3? Yep, it's 3 to the power of 1 gives me 3. So this is 3 plus 1/2 times 1. Or 3 plus 1/2, or 3.5. Or 7 over 2. Questions there? Very good. All right, so part of your assignment here, with no calculator, use the laws of logarithms to, obviously you're going to compress these, right? You're going to write these maybe as a single logarithm, or expand to simpler parts, and see if you can solve this without a calculator. So go ahead and Take a few moments to do that. Okay, answer to A. Get that? All right, 1.5 for B. Now C, okay. C looks a little scarier. All right, let's focus on the brackets first. Actually, I could probably take this, undo this power rule here. So this is actually log of 12 squared, right? Base 2. Minus, what's this going on in here? This is log of 6 base 2 plus, I'm going to write this exponent up there, log of 27 base 2. This is 1/3 to the power 1/3, or cubed root, right? So I've got log of, I'll just go 144 here. This is log of 6 base 2 plus, so this is going to be cubed root of 27 is 3. Log of 3 base 2. So now I look at this and I say, okay, well I'm adding 2 logs with the same base. And it's actually really important that these have the same base, because this rule only works when we have the same base, remember. So I'm going to go log of 144 base 2 minus log of, what's 6 times 3? 18 base 2. All right, so up to this point, we're in tough here for solving for this base 2, but I could do one more thing. What's 144 divided by 18? Now, without a calculator here, how do you approach this? Okay, any ideas? I mean, can you simplify that? Divide them both by 2. Can you keep going down like that, maybe? All right, you could do that, couldn't you? 72. So this is 72 over 9. What's 72 over 9? Yeah, so that's log of 8 base 2, which is 3. So right up until the very end, you wouldn't be able to do any of this in your head, probably because they don't really work, right? 2 to the power of what is 6? That's a decimal. But when you get down to the end, using all of your rules, you can get down to an answer there. All right, here's your sum for 8.3, and that's just a few examples of using the power rule there. Questions?
On our test, will there be a bunch of stuff